Alrighty, 8th graders, this is going to be the volume of pyramids and cones. This will come after section 8.7, and the reason why is because I feel like the book put them in the wrong order. So this is after section 8.7, and then the next section is 8.8. Seems strange. Okay, what do we have here are pictures of pyramid on the left and an ice cream cone on the right, because we are going to be working with pyramids and cones. Now, surface area is tough. Volume's pretty easy. Today's going to be volume. Tomorrow's going to be surface area. Okay, now we're looking at what we would consider a pyramid, a normal pyramid. Okay, you see here down at the bottom, we call this the base. Each of these corners are called vertexes, and the very top is called the apex, or you can call it the vertex. Okay, same thing. Now, if you look at this figure, this front side here is like the front of a triangle, okay? And then there are 4 of them that should be identical to each other. Okay, well, they'll be identical if the bottom's a square. If they're a rectangle, there'll be 2 of each. I'll show you in a little bit. But the bottom here is going to be a base of a rectangle. So you'll have a rectangle base and then triangles on each side. So what the formula is going to look like is this. The volume is 1/3 times the area of the base or the bottom times the height. Okay, write this formula down. I don't want you to memorize it. Okay, so we have a triangular pyramid over here, and the only difference between a triangular pyramid and a rectangular pyramid, which we just had, is that a triangular pyramid has a triangle on the bottom. So therefore, the volume of a triangular pyramid is a rectangular pyramid divided by 2. Meaning you do 1/3 times the area of the base on the bottom times the height, and then you divide it by 2. Okay? The other way to figure this out is if you do the area of the base as a triangle, you'll end up getting the answer. Okay, we'll see examples and it'll make a little bit more sense. And finally, the cone actually has the exact same formula. A cone, the only difference though is that the area 1/3 times the area of the base is a circle. Therefore, you'll have to do pi r squared to figure that one out. And then the height will have to come from the apex straight down to the center of the circle. Okay, so let's do some examples and see what these look like. Here's a pyramid, okay, and we see that the front here is 80, the back right side is 80, that means the back will be 80, and this other side over here will be 80. So we have to do 1/3 times the area of the whole base times the height, okay? The area of the whole base here is going to be 80 times 80, which will be 6,000? 6,040? I'm not entirely sure here. Oh, 6,400. So we'll do volume is equal to 1/3 times 6,400, and the height is from the apex straight down to the center of 100. So now we're going to do 1 divided by 3 times 6,400 times our 100, and so it's going to be 213,333. Wow. Now, the labels, because we're working in volume again, it's going to be meters cubed. Okay? Formula will always be the same. 1/3 times the area of the whole base times the height. Okay? So, here we have a cone. Same thing. Volume is going to be 1/3 times the area of the base times the height. Okay? Except now the base is a circle. So, I'm going to go over here and do our b, and that's pi r squared. Well, the radius is 18, so it's going to be pi times 18 squared, and 18 times 18, it's going to be 324. So therefore, our answer is going to be 1/3 times 324 pi times our height, which is 1 foot. But here's the problem. This is in inches, this is in feet, so this has to be converted to 12 inches. Okay, you could convert them both to feet, but inches is definitely the better option here. So then I have to do 1/3 times 324 times 12. Times 324 times 12, which is 1,296. We got to throw the pi at the end. And the label has to be inches cubed because we're working in volume. Okay, so there's the answer for that one. Okay, here are two problems that we're working with. I want you to try both of these. Bottom here we have the Louvre. It's a big giant pyramid. And then the top here we have a hedgehog hiding in an ice cream cone. We only care about the ice cream cone, not the hedgehog. Okay, give it a try. Okay, so I'm hoping you gave this a try, and we'll see how we do on each of these. The formula is always going to be 1/3 base times height, and we have to figure out the base. Now it's a cone, so the base is a diameter of 9, so that means our radius is 4.5. So we have to do 4.5 squared times pi. Which is 20.25 times pi. So that means our volume is going to be 1/3 times 20.25 times pi, times our height, which is which is 10, sorry. Now, a nice little trick to actually do these is you don't have to do the 1/3 at the beginning. You can actually do 20.25 times 10, and then you can take that answer and divide it by 3. That's the same thing as multiplying by 1/3, dividing by 3. So 67.5 pi, and the label is going to be inches cubed. So we move to the bottom, and our triangle here is once again 1/3 times base times height, and the base is a rectangle that is 80 times 60, which would be 4,800. So our volume is going to be 1/3 times 4,800 times 100. So that'll be 160,000. Is that right? There it is, 160,000. Yep. And the label on this will be cubed feet. Okay? Questions, bring them tomorrow to class. We'll work on these. Here are the problems that you're going to be working on. There are just 9 of them. Nope. Yep, 9 of them. All right, we'll see you tomorrow.